Understanding memory management in programming.
Memory management is a critical part of software development. It determines how programs allocate and reclaim memory. There are two main approaches: manual memory management, where programmers directly control memory, and automatic memory management, where systems like garbage collectors handle memory for you. Choosing the right method impacts performance, reliability, and complexity in your code.
What is manual memory management?
Manual memory management requires programmers to explicitly allocate and free memory. Languages like C and C++ use functions such as malloc and free. This approach gives complete control over memory usage, but also demands careful tracking to avoid issues like memory leaks and dangling pointers. It offers efficiency, but increases the risk of bugs and vulnerabilities if mistakes are made.
What is automatic memory management?
Automatic memory management relies on a runtime system to allocate and reclaim unused memory. Examples include Java's garbage collector and Python's reference counting. Developers don't need to manually free memory, which reduces certain classes of bugs. However, the timing of memory reclamation is unpredictable, which can lead to performance pauses during execution.
Pros and cons of manual memory management.
Manual management offers maximum control and can result in faster, more memory-efficient programs when used expertly. This control is essential for systems programming or embedded devices. However, the complexity leads to frequent errors. Forgetting to free memory causes leaks, while double freeing can crash programs. It requires disciplined coding and thorough testing.
Pros and cons of automatic memory management.
Automatic management simplifies development and greatly reduces memory errors. It's especially advantageous for large or complex projects. Developers can focus more on core logic rather than memory safety. Nonetheless, it can introduce unpredictable performance and higher memory usage. Fine-tuning automatic systems can be difficult, and real-time applications may find these pauses unacceptable.
Choosing the right approach for your project.
The best memory management strategy depends on your project's needs. Manual management is suited to performance-critical or low-level applications. Automatic management works well for productivity and safety in most modern applications. Understanding the trade-offs between control, safety, and performance helps you select the most effective coding practice for your next project.